All right, we're going to pull back the curtain on the digital world and take a look at the invisible architecture that, basically powers our entire lives. It's called system design, and it's the real reason your favorite apps don't just crash.
I mean, have you ever really thought about it? How does Netflix not just die during a massive show premiere? Or how does a shopping app handle millions of people hitting buy at the exact same second on Black Friday? Well, I can tell you it is definitely not magic. It's something way, way more deliberate.
What it is a carefully crafted blueprint. Think of it like that. It's the set of really smart architectural decisions that lets software be reliable, super fast, and, crucially, grow to a massive scale without just falling apart. So, here's the plan. In the next few minutes, we're actually going to build a high-level blueprint for a modern app. And along the way, we're going to uncover some of the biggest secrets behind the software you and I use every single day. You ready? Let's do this. Okay, first things first. Every great structure needs a solid foundation, right? For our app, that foundation is all about communication, and that happens through something called an API, an application programming interface. The easiest way to think about it, it's like a menu at a restaurant. It tells you exactly what you can order and precisely how you need to ask for it. So let's put our app to the test. Imagine this, and we've all been there. You're about to buy something online, the connection lags for a second, and you get nervous, so you click Pay Now again. Uh-oh, are you about to get charged twice? This is a classic system design problem. And the answer is this brilliantly simple concept called an idempotent API. It's just a rule we build into our blueprint that says this pay operation, well, even if we get it 10 times, it only actually does something the very first time. Your first click, it processes the payment. Every single click after that, safely ignored. Phew. Just that one little rule makes our whole system so much more resilient to glitches and, nervous clicking. All right, so our app is a hit. People love it, our foundation is solid, but that success brings a whole new kind of problem. A good problem to have, I guess. We're getting way too much traffic for just one single server to handle. It's time to scale up. The question is, how do we go from just one server to a whole fleet of them and make sure all those millions of user requests get sent to the right place without everything grinding to a halt? I mean, we can't just send them randomly, right? That would be total chaos. What we need is an intelligent traffic cop. And our traffic cop is called consistent hashing. It's this super clever algorithm that maps user requests to servers in a really predictable way. But here's the really powerful part. If a server crashes, or if we need to add a new one to handle more traffic, only a tiny fraction of requests need to be rerouted. We avoid this massive system-wide reshuffle. That's the secret to scaling up smoothly. Now, as we're handling all these users, it's really important to get this one key distinction. Are we handling a bunch of things at once, or are we doing a bunch of things at once? Let's use an analogy. Concurrency is like having one cook in the kitchen juggling multiple tasks. Chopping veggies, then stirring a pot, then checking the oven. He's handling a lot. But parallelism, that's like hiring a second cook, so one person can chop while the other stirs at the exact same time. And modern systems, they use both to be incredibly efficient. Okay, so our app is now huge. It handles payments, shipping, user profiles, reviews, the whole shebang. And trying to cram all of that code into one giant application, what we call a monolith, it just becomes a nightmare to manage. So what do? We break it apart into smaller, independent pieces called microservices. But as you can probably guess, this creates a whole new kind of complexity. Think about it. If our payment service is now a totally separate thing from our user profile service, how in the world does one find the other to talk to it? I mean, their locations, their addresses on the network, they can change all the time as we add or remove servers. They desperately need a way to find each other on the fly. And the solution for that is called service discovery. The best way to picture it is like a central, self-updating contact list, but for all of our services. When a new service comes online, it just registers itself in the list. When another service needs to talk to it, it just looks it up. No more hard-coded addresses. It's just a dynamic, living directory. Okay, but wait. This separation, it creates another really tricky problem. Let's say a single customer order involves the order service, then the payment service, and then the shipping service. What happens if the payment goes through perfectly, but then the shipping service fails? We absolutely cannot leave a user charged for an item that is never, ever going to ship. This is where a concept called the saga pattern becomes absolutely essential. So, as you can see in this timeline, when that shipping service fails at step 3, It kicks off a chain of what we call compensating actions. Basically, the system starts working backwards. It tells the payment service, hey, you need to issue a refund, and then it goes back and tells the order service to just cancel the whole thing. It's like a financial cleanup crew, ensuring our data stays consistent across all these different services, even when things go wrong.
So, our system is scalable, it's resilient, but none of that matters one bit if it's not secure, right? We have to build a strong front door and have a totally reliable way of knowing who's who. So this brings us to a crucial security question. After a user logs in one time, how does our system trust them on every single click, every page view, every single request they make after that? Because one thing is for sure, we absolutely cannot send their username and password back and forth with every action. I mean, can you imagine? That would be a massive security nightmare. The modern solution to this is something called a JSON Web Token, or as you'll hear it, a JWT. And it works kind of like a secure VIP wristband at a concert. You show your ticket just once at the gate to get the wristband. Then, for the rest of the night, you just flash the band to get access everywhere. You don't need to pull out your ticket and your ID every single time. A JW4 works exactly like that, but for an application. So here's how that flow actually works. Step 1. You log in. The server checks your credentials, confirms it's really you, and then issues this special cryptographically signed token. That's the JWT. That token gets sent back to your browser, which then includes it in all your future requests. And here's the key part. The server can instantly verify the token's signature all by itself, without having to do a costly database lookup every single time. It's fast, it's secure, and it's what we call stateless. And just like that, there you have it. In just a few minutes, we've basically pieced together the core blueprint of a modern system. Now, of course, it's a constantly evolving puzzle, but these fundamental building blocks, these are the ideas that make today's internet actually work. So let's do a quick recap of the blueprint we just built. To make it safe from things like double clicks, we used idempotent APIs. To handle massive growth, we brought in consistent hashing. To manage all that growing complexity, we used service discovery and the Saga pattern. And to secure the front door, we locked it down with JSON Web Tokens. See? Each piece solves a very specific, critical problem.
And all this brings us to a final thought. Look, we have really just scratched the surface here. As our applications start to incorporate more AI, as they handle unimaginable amounts of data, and become even more distributed, this blueprint is going to have to evolve. So the real question isn't just about how systems work today. It's about what invisible architecture we're going to need to invent to power the world of tomorrow.